Hi everyone, we are going to do the last topic of chapter 15, binary expansion. So this bit is using general terms. It's quite useful. Let's quickly revise on how we expand it first. So a plus b, let's say a plus b is two terms to the power n. So if we do the first term, will be n to 0 because always start from 0. So for a, the power of a, we go from n to 0. The power of b, we go from 0 to n. So that would be a to the power of n, b to the power of 0, yeah, which is 1, yeah. And then the second term will be n choose 1, a to the power of n minus 1, b to the power of 1, yeah. And then you keep going and choose 2, n minus 2, b to the power of 2, yeah. It's not for every single term, the power of a add up to the power of b will always equals to n, yeah, because a decreases, the power of a decreases, the power of b increases in the same rate. So the third one would be a choose n minus 3, b to the power 3. So all the way to n choose n, a to the power 0, b to the power n, okay. So that means we have a general term if we know which term we're looking at. So if we do n choose r, let's say the rth term, a to the power, if you see the pattern there, will be n minus r, b to the power of r. So that is our general term, okay? So that's the thing that you need to remember. So let's have a look at this one, the expanding general term for this, okay? So I leave the general term in the top. So in this case, n is 20. So that will be 20 choose, we don't know what r is. For general term, we use r. So 8 in this case is 2x squared to the power of n minus r, which is 20 minus r. And then b in this case is this whole lot, not just x to the power of negative 1, okay? Make sure if it's negative, you include negative 1, the negative sign in there too. That will be negative x to the power of negative 1 to the power of r, okay? So we can also simplify this as well. So I show you what I meant. So power of r, 2, we can separate out using index law. So 2 to the power of 20 minus r. And then x. Right, now is x squared here to index that. So according to index law is 2 times whatever's on top mine here. And for the next bit, so you got negative there, you can separate as negative 1. So negative 1 to the power of r, yeah, all times. Apologize. And then we got x negative 1. So again, negative index law to become minus r, okay? So that case, let's put all the numbers at the front to the power of 20 minus r times negative 1 to the power of r. Now these two, because according to index law, we can just add or subtract the index, isn't it? So 20, that would be 40 minus 2r minus r, which is 20 minus r negative 1r times x to the power of 40 minus 3r. That is our general term. So we basically combine the two x's together. If you want to find a term, is extremely easy. Okay, well, I'll show you one example here. So let's do the first one. Let's do the general term first. So it will be n is 8 this time. So a choose r. We got what x here. So the first term is x. So x to the power of a minus r. Yeah, n minus r. Yeah. Second term will be wait. Before we do that, I'm going to simplify this a little bit. X to the power x plus 1 over x is the same as x to the power of negative 1, yeah? So it's 3x minus 1, power of 8. I apologize for the long over. I don't know what happened to school. It's like machines everywhere. Anyway, so this is the first term is x. The second term will be 3x to the power of negative 1, yeah? To the power of r. Now we can simplify this bit. So Oh yeah, right. Some of these on the bottom. Now a choose r, x power of a minus r, and then we can take a 3 out. 3 power of r, x power of negative 1 times r is negative r. Well, we can simplify this bit. So a choose r. Let's put number in front first. 3 power of r. In this to a minus r, so 8 minus 2r. Okay. Wow, this is our general term. Now, because we're looking at the term that is independent of x, what does that mean? There's no x in there. So that means we eliminate this one. The only case this term is eliminated is when x to the power of 0. That means 8 minus 2r equals 0. 8 equals to 2r, r equals to 4. So, well, we know what r is. We can solve the whole thing, yeah? So it's a choose 4, 3 to the power 4, x to the power 0, because we know that is 0. You can put it in double check, but we know that x is 0. So all we need to do is time the calculator. Let me get a calculator. So is a choose 4 times 3 to the power 4. So a choose 4 times 3 to the power 4. The answer is 5670. Simple. You can quickly pause this video and do the next 3. Once you're done, here's the solutions. I hope you do them correctly. Just be careful about second one because it's minus. So you have, because it's minus here, you should have minus here. And your answer, because I is 9, your answer end up being negative as well. So yes, let's move on. So another thing, this one's slightly harder. Well, let's do some harder questions. Obviously not doing easy question all the time. So in this case, we write down the term of x power r expression of that. So why don't we just put in general term first? Like every time we do this, it's better to just put in general term. So again, n choose r, a to the power of n minus r, and b to the power of r. So a is at the front, so n is 12. Okay, so 12 choose r. We're still using the r term here. 8, a to the power of n minus r, so 12 minus r. So b to the power of r. So in this case is bx to the power of r. Okay, don't wait. It's actually negative b x to the power of r. Okay, we need to simplify this a little bit. So and choose r, a to the power of 12 minus r. We need to take negative b out. So negative b to the power of r, and then x to the power of r. So we find the general term with x to the power of r. So first bit is done. Now b. Well, we kind of need to times 1 plus x in here. So and then find the coefficient of x to the power of 8. Well, this is a little bit more difficult. So what about we just times the what about we just times the general term, because we know exactly what that is. Okay, so 1 plus x, we times the general term here and choose r, which is 12. Sorry, apologize. So it's 12, choose r, 12 minus r, negative b, r, and x to the power of r. Okay. Let's call that there. So we times the in binomial rainbow method. You times both of the terms. You got 12 choose r, a to the power of 12 minus r, negative b to the power of r, and x to the power of r, plus 12 choose r, a, 12 minus r. Because it times x, so the only thing changes is the index of x on the second one. So it will be x to the power of r plus 1. Now, this is a really tricky part. Because we're looking at the coefficient x to the power of 8, in this term and this term, the r value will be different because x power 8 for this r will be equals to 8. For this one, because we're looking at r plus 1, if you're looking at the coefficient of x to the power of 8, r plus 1 equals 8. The r is 7. So these two terms are a different index. Okay, r values are different. So I'm going to move on with this. So the first bit, we are substituting x equals to 8. R equals 8, yeah. So there will be 12 choose 8. 8 to the power of 12 minus 8 is 4. Negative b to the power of 8. And then x power 8. So we got that. The first one easy. Second one, r is 7 this time, not 8, okay? Because we got the index of r plus 1. So in this big term here, we need the r equals to 7. So 12 to 7, a to the power of 12 minus 7 is 5. And then negative b to the power of 7, because r is 7. Whoopsie, I forgot the r here. And then x to the power of r plus 1, 7 plus 1 is 8. So in both of the terms, the coefficient is both x power 8. So we can add the coefficients here. That's the main purpose of it. And then we're going to simplify all those. We work out those two. Because this term is negative to the power of 7, the second number ends up being negative. The first one is negative b to the power 8. So that means it ends up being positive. So we're going to simplify this a little bit more. Okay, up to here, we moved both of them to one side. Oh, wait, no, wait. Because we set the coefficient of x to the power of a is 0, so these two, well, we can take off the x for now because we don't really need x anymore. We talk about the coefficient. So the coefficient equals to 0. Now, this is more interesting because we can equal to each other, okay? So move 1 to the outside. This is a 7, by the way. It does look like a 1, but this is a 7. So move those to the outside. Now we got this. We got a lot of a's and b's. We can just simplify those. So a to the power 4, b to the power 7. After we divide by that, we got this. We can divide both sides by the left hand side. So left hand side equals to 1. And then we got 8 a over 5b. So if we divide by 8 over 5, we got 8 over 5 over 8 over b a over b. So we find the ratio of a and b. So a to b is 5 to 8. So that's how we work that one out. It's a little bit complicated. You probably need to go through this more than once, but this is one of the harder questions in this topic actually. So I hope you understand the general terms and how useful it is. I've got a few questions for you to do as homework. Hopefully go through this. It should be really helpful going through this topic because general term is quite good when you do any of the binary expansion questions. Okay. Hope you enjoyed this video. Thanks.